We're here with Uli Baretzky, and you're the head of development for racing projects and racing engines for Audi. Um, Audi Sport have put a lot of money and time into the creation of the super touring engine. It's got very tight regulations.
Yeah, the regulations are very, very tight. We are basically starting with a production engine, means block, cylinder head. All these very important, very expensive parts have to be taken off the production line. The volume is reduced to 2 liter and the number of valves to 4 per cylinder. The revs are limited to 8,500, and that's the rules we have to respect wherever we run.
Now, to do that, what do you have to do to make a good super touring engine?
To do a good super touring engine or a good race engine means always the same. You have to find a good compromise between performance, reliability, weight, and costs. And we started in the late days of 92 to get these engines after we have got the order to race in France in 93. And we had to do this job within 4 months from start on.
Yeah. Design then is obviously the first priority, but making sure that you can achieve the engine in time, I suppose, is another.
Yeah, we have one side is to respect the time you need to construct, to make the design of the engine. Besides this, you have also to speak with the people who are producing the parts, how many time they will need to get them involved very, very soon in the production. So then you can find out the final point where you have to get the drawing ready, so they have the time enough to produce this part you use then to fix and to build up a complete engine in time.
So you wouldn't really build the ideal engine first time round.
No, you have to do a good compromise between your ideal engine and what is realizable in this time.
No reaching for the stars then.
Not reaching for the stars in the first moment, but to dream of it is necessary and to keep the dream.
Now, let's have a look at an engine. You've got a drawing behind you here. What do you actually do, and what are the differences between a production engine and a super touring engine then?
Okay, to show it very easy for you, this is a production cylinder head like it is used. This drawing is used for production, and all the areas that are white shown here means we have changed it. This is for instance the combustion chamber, which changes from a bore diameter of 81 to now 85. That means that the shape outside is changed. The valve dimensions have been changed for sure, because for more performance you need more and bigger valves, and not more but bigger valves. And the most important changes are made on the exhaust and on the inlet part.
Right. So what you're trying to do is really smooth the airflow and get what? Just more power, or is it power and torque?
For a race engine means you have the same situation like for a production engine. The driver is your customer and he must be happy with this engine in every situation. So he needs a certain comfort, not a very peak power engine where you can only use between 8,000, 8,500 and below he is lost. So you need a smooth, an engine with a lot of torque, which is pulling out the car from, let's say, 6,500 up to 8,500, so he hasn't to work so much with the gear.
And doing that in these very strict parameters and regulations, how do you continually evolve the development of an engine? What do you do? Is it a question of testing new parts, or with the number of cars you're running, you must have great difficulty in just doing that?
Yes, you are going away from the basic design we made in 92. And then we concentrated from one year to the other on certain items. One thing was the weight we had to cut off. The other thing is the constant improvement and growing up of the performance, which is basically influenced by the cylinder head. And you are using also all means of the Audi can afford to us, means also CAD and flow calculation, to get more and easier the air into the cylinder head to produce more and more power, and then to get it out without with the lowest resistance in airflow.
Now, all of that must mean then that with 7 championships, 20 cars working around the world, that what you have to do is to plan a lot in advance to get to the situation where the same engine is delivered to all your customers and all the teams all over the world.
Yeah. Racing in this dimension with 20 cars all over the world means also a lot of work and a lot of experience in logistics. So you have really to work together with very, very good and strong partners we have inside Audi Sport, inside Audi, also at Audi Sport. So it is not enough to build 1 or 2 very good engines. You need for every 20 cars the same level of engines, and we have achieved this in the past. We are working very hard on this. That means that you must plan very early what you are doing next year to order the parts, to get it in the quality you need it, and then you build up the engines, deliver it to the customers or to the works teams, and then you are running it.
Right. So we're now at the end of 1996. You've had a very successful season. How long do you have to plan for 97?
The 97 season starts, if you want, in the design department in the early days of 96.
Really?
So when the race engines of 96 are delivered to the customer, we already think about a new step of engines, because development cannot be started in autumn and be ready in this level we are working at the moment. If you compare us with the BMW and all the other competitors, they are working very hard, and the gap between the 10th and the first place means 0.8 of a second. So you have to get out everything possible of this engine, and so you have to start your development very early to be ready in time.
So the areas that you look at for 97, without too many trade secrets, obviously.
The area we are looking at is like always the same. We are improving the airflow, we are reducing the weight, we are reducing the friction in our engine. This means we are continuing the way, we are looking for the stars and following the way to the stars.
Right.
And we do it in reasonable steps, so we'll get the parts, and we get the parts also proven. So with dyno tests, with endurance tests, so we can rely on the reliability of these engines for next year.
And how much of this technology then finds its way back onto the road car?
This is a difficult question. I'm very often asked. I would say you will hardly find one part you can say this is made in race engine and then put it into a production engine. To make race engines in a factory like Audi, we are doing it inside Audi, not outside, means that a lot of people of this company are involved in these affairs, and they are learning how to do things very quick and very accurate. And this attitude and this learning comes automatically in their way how they treat production engines and production parts.
Right. So really, the differences and the experiences you learn in racing, you pass back into the road car.
Yeah.
But the experiences also that the road car has come to you.
Yes.
It's a very big balance.
Yeah, we learn a lot of our road car development, especially in developing new tools of calculation, of stress calculation, of flow calculation. So we try always to be on top of the development here at Audi, to use as soon as possible means they have found out, because we are not so many people to look around what is existing on the market. So we are very happy if they say us, we have something new, look at this, whether it's useful for you or not, then we will do it.
Right. So in particular, you're mentioning the airflow in and out of the cylinders. Tell us something about what you've improved in the drawings here. What have you done?
Here was a drawing shown on the desk here, this special cylinder head made for investigation to find out how we could improve the combustion, the airflow in, the airflow out that influences this combustion system. And here is shown the intake port and the exhaust port in red and blue. And the things that are very important on this drawing are these two plugs. It looks like a plug.
Yeah.
This is a quartz where we can find out the pressure in the moment the mixture is burning inside. We can record it, and then we analyze it later on. And so we can look about an improvement of the airflow of the intake and exhaust port. And this is shown on very different side, because the production head is not made to introduce these parts originally. So we have really to find out where we can use and where we can introduce these parts.
Now, that obviously brings you on to the subject of fuel consumption, which I'm sure isn't a great parameter in a race.
Very good, very great.
But on the other side, I'm sure you must be one of the most efficient petrol consumers that there is.
Race engines, even if people don't believe it, must be very, very high, very efficiency engines, because every volume of, or every quantity of gasoline or fuel you have to take away is weight, is extra weight. You must not carry on if the engine is reasonably made and doesn't consume so much. So our power consumption compared to the power we are producing should be one of the lowest of all Audi engines.
So what you're saying is that even though it produces, 300 brake horsepower, let us say, pound for pound, it's probably more efficient than the road engine.
Yeah. We are looking to find out 500 grams everywhere, and 500 grams means 0.7 liter of fuel. And if we can avoid to carry on this weight, we will do it for sure. And this is one of the main directions of developing, means low friction of the engine, means low consumption compared to the power.
Okay, right. So now we've moved from CAD/CAM, the design of the engine, to the actual reality.
Yeah.
And here we are, we're in the main engine shop. How many engines do you build here to support all of your teams?
Last year we built about 320. This year we have achieved about 305 till today.
Right. So each engine then has its own history, its own book of information, its own life story, if you like.
Yes, all the main parts of this engine are registered with numbers, and they will be followed by kilometers or hours on the dyno, and all is together in what we call the history of the engine. In one book, we keep always together with the engine.
Now then, let's have a look at these specialist parts. If you have a look at the pistons in particular, what's so special and what makes these so different to the production engine?
The first thing you may judge yourself, if you turn it around, they are very, very short, very, very lightweight. And you see along this distance on the compressor height, what we call the compressor height, means that this piston is not made for a long life. So it's really for a race engine. That means it is used for about 2,000 kilometers, and then it will be changed against a new one.
And the same for the piston rings and the conrods themselves?
We are using a 2-ring piston. You may see here, compared to a production car, that means it has a 3-ring piston. This helps us to reduce friction, and is generally used in racing. People are still trying to go to 1 ring, but I think it's not so very easy to achieve this.
And what about the conrods themselves? They are, again, very special.
Yeah, this conrod is an H-shape conrod, very light, very reliable, and is produced in Italy. We are very happy to have it. And it helps us really to reduce friction and power loss in friction due to weight reduction of this conrod.
Now, you mentioned earlier on about how the parts and the engine themselves has to do a specific life. How much life do you give an engine before you rebuild it?
The engines we are building up before we are delivering to our drivers are tested on the dyno for 24 hours, and then we tested in Monza for endurance test in the car for at least 1,500 kilometers, better 2,000. And this is exactly the life we give to the race engines. We are using them widely till 1,700 or even 2,000 or even more kilometers if it's necessary, before we rebuild it.
So what would, for instance, a block life be?
A block life, when we have no failure, no cracking in, can be 10,000 kilometers or even more.
And that's quite remarkable for a race engine, isn't it?
Yeah, but you have to keep in mind the block is a production block. It's not a special race block. It's only it's only machined for our purposes, but it's basically a production block taken out from the chain.
And that really, it makes it even more remarkable because, you get Formula One engines which are just doing a couple of laps and then thrown away completely.
Yes, to race an engine for such a time means a big challenge for us. And there we see also a lot of advantage also for our production colleagues here, because we make a lot of steps to improve the reliability and all these things on our engines.
So we now moved on to another step in production. The engine is virtually complete apart from the head. What looks so remarkable is the height from top to bottom of this engine. And obviously you're trying to make it as small as possible to get the weight distribution right in the car.
Yeah, for sure. We have tried to get this engine as low as possible in the car, to have the roll and center of gravity as low as possible in our car to improve the handling.
Right. So this means that really you've now adopted a dry sump oil system, what does that do in comparison to the normal production engine?
The dry sump oil system helps us first to make sure that the engine is supplied with oil in any condition on the track, in the braking or accelerating or cornering. And the second one is that we can lower down the engine as low as possible, because the reservoir of the oil is not below the engine, so somewhere apart. that allows us also to play a little bit with the volume we need of oil for this engine during the race.
And you mentioned also about you have a book for each engine.
Yeah.
That literally follows the history through in every different dimension.
Yes, so we have for every engine we are building here, we have a book, a documentation.
Yeah.
That means inside we have all the clearances, all dimensions that are controlled, that are checked, and they are all documented together. This book follows the engine wherever it goes.
Right.
And when it is rebuilt, we will add the additional terms that have been changed on this engine from the first building.
So you can literally follow any engine, any block or any component all the way through. That would be quite a remarkable exercise.
This helps us a lot to make sure the quality, because by this means we can avoid to run parts that have become too old, or to combine old parts and brand new parts. It's not a reason not reasonable to use this for economic reasons.
And you find then that by tracing it, you can also keep if you have component failures, you can follow that through to every other engine.
Yeah, this goes still a little bit farther than this motor book. From this motor book on, we follow a very, very good documentation in our workshop outside here, where all the parts are specially controlled, and for every part we have a documentation, so we can also find out some lots. If we have a lot of spring or something that are not working like it should, we can find it out even in the engines already delivered. We can pull them back and to change these parts without blowing an engine.
So we're now at the final stages. The engine is virtually complete. Obviously the important thing here is the cylinder head, and that's really where the majority of work is done, isn't it?
Yeah. The cylinder head means is the head of the engine. Right. What we call most of the influence on performance is imposed.
Right. So you have a 4-valve engine here per cylinder, 2 inlet and 2 exhaust valves. What are you trying to build into the performance of this head, and what do you do to it to make it work so well?
Okay, what we are doing is first to improve the airflow, the gas flow through the cylinders, so it make it easy for the air to come in and very easy to get the gases out of the engine. The camshaft helps us to open and to close the valves in the right way, in the right time, to get and to keep the air in and to get these gases out in the right moment.
So you've developed obviously special camshafts for this, how do you work and blend those with the sort of inlet and exhaust of the engine?
Okay, these profiles we are using for the camshaft are specially made for this purpose, to get an overall usable torque and power ratio for this very small range of rounds we have to use till 8,500. So the drivability of the engine and the power is part or center of the development we are doing here.
So compare for us the production engine. You've got a standard 2-litre Audi A4 engine. Power and torque characteristics. The Audi 2-litre engine would give what, 140, 150?
In the A4, this 4-valve engine doesn't exist anymore. We are only using the next step, the better step, the 5-valve engine, which we are not allowed to use according to the reglement in our race cars.
Right.
And to compare this 2-liter engine with a production engine, we are using 5-valve 1.8 in the A4, which means he has a performance of 125 horsepower compared to more than 300, exactly 305 we are having here, under different conditions for sure.
Yeah. Now, with the engines that you've built here, they're all shipped then back to Audi Sport in Ingolstadt or to the teams direct?
Yeah. All these engines built here are then run on a dyno, a special program for 3 hours. They are tested, and from then on they came into the big box, and from there they are distributed wherever they are needed. That means that every driver, every team can be sure that they get the same material everywhere.
Now, do you send out an engineer then who will work on the engine at the racetrack as well?
Yeah, these engines are a little bit sophisticated and not so easy to handle, so we need normally for 2 cars running 1 engineer, especially for the engine, who is going with a DARAP system, a data recording, and then he has to suit this engine whether things are going well or we have to change or to adjust something or to avoid any damage.
Now, the final thing, obviously, is the electronics that you put on the engine, because that's moved on a great way as well. How can you influence the performance of the engine electronically?
The basic performance of the engine is given by the engine itself. The electronic can only help to maintain the level. And if you don't handle it right, you can only lose performance, but you cannot create performance. What you can create with a electronic is reliability in terms of control, self-helping system, redundant systems that are controlling themselves and showing us if something going wrong.
Right. And fuel? Can you introduce more fuel into the engine by using the electronics?
Let's say we can easily introduce exactly quantity of fuel we need,
Right.
according to get the maximum power.
Now, you've obviously got an engine here that's very powerful, but as far as economy goes and the fuel it uses, what do you reckon this engine will give you in miles per gallon?
Depending on the track condition we are running, we have a consumption of about 9 miles per gallon on this engine under full throttle conditions.
Now, that compares obviously to a road car that can give anything between 20 and 40, depending upon the engine specification. But from an environmental viewpoint, it's probably producing that and using the petrol much more efficiently than the road car.
Yeah, for sure, we are trying to use the fuel as efficient as possible. Besides this, we are also using a catalytic system, so we don't have to be ashamed against our people who are looking for the environment.
Right. So that it's also one of the cleanest engines around then.
I would think so. I would not hope so, but I think so, yes.
Okay. So we're now here at the cylinder head part of the factory. What exactly are you trying to do here? You talked about the blends of air and inlet and exhaust. In layman's terms, what are you looking for?
Okay, first thing we are looking for that every port and every combustion chamber is equal to the other to give the maximum performance due to volume and to airflow in the cylinder.
So you're improving the airflow greatly then, and coming in and obviously getting rid of the engine. Does that mean then that you do a lot of polishing of the heads and the valve areas?
You could have the impression, but we do only very, very few things by hand. Most of this cylinder head is made by machine to guarantee the fact that the things are all equal. So all ports are machined and only little bit made by hand, but it's only polishing a little bit.
And this really is the one area that obviously gives you this vast increase in power over a normal production engine.
Yeah, this is one of the secrets or one of the reasons why this engine is so powerful compared to a production engine, and also regarding the fact that you are running at very higher levels than you are doing in a production car. You have to face this fact too.
And all of this is done by machine?
All of this is done by machine except then fitting the valves in. This is handmade, must be handmade, because there are really things to respect you cannot do with a machine till now. The combustion chamber, for example, is eroded.
Right.
Do you just put into the valve inlets?
Yeah. The valve inlets on this side, a copper beryllium, is a very hard material to avoid wastely the wearing of this seat, and here the exhaust as well. Not be shot.
Yeah.
It's a good man. I put him from Mercedes.
All right.
From the school.
Yeah.
Then he went to Mercedes because didn't done a job, and then I met.
Only you at this. Sorry, up there, so he's actually serious, eh?
And he's really is working like this one. Oh, this here is dolly here. I sent it to Australia. Choke down. Okay, I can see. And all this sports, he can really busy. Yeah, absolutely. Travel the world. Yeah, but plastic was very out there. Went for a test over the Lunga. Then we had to chamber the winner. Then we had to go to Belgium or Belgium. We had to go to Dubrovnik. And another colleague was called in the afternoon of Wednesday saying, "Hey, I'll take your bag and go for the Lunga to roll because we had continued the test for one day. Then count them as quick as possible to Dubrovnik because we had to raise better." Absolutely brilliant. Oh, that's.
But the idea, same guys you get those, the old guys too, you're getting older very faster.
So we do. One thing what it's like trying to do the British on set. And then you get to the jerk on Sunday.
Ring your heart, you know. Really so free. Right, you very far. When I was at the Formula One, I was a good to the mate as an end working on the dial. As one of the people asked him, and your wife says, I work with some, he says, nothing. Your wife. But he says, I come home with Jesus left. And the wicked is. There's a feeling about the behavior of the engine. It's strange. They look at the color and the size of the gear and all this. By this opinions, is even going on. Now, what would that go? I get back into the car. Yeah. Maybe. Oh, they. Oh,
Really? Okay.
Ready?
Back of the hand.
Yeah. Back of the hand.
Yeah.
Underway.
That's it. That's it.
Okay, thank you very much.
Yep.
Okay, rolling.
So computers and CAD/CAM have obviously made a huge difference to the production times of your engines and to the design time. What revolutions have come about, really?
One thing that helped us a lot was to get complex parts which needed a lot of time to get it designed, can now be done within few days. And from these parts on, you can make a lot of further on cutting or developing or designing. You change it very easily. And so the quality of the design and the quality and the reliability of the design is much better than you do it on pencil.
Now, with these types of drawings and the fact that you can revolve and see the parts so easily, can you literally now design from here and go straight to production?
This is possible by some parts, and a lot of manufacturers that are supporting us need this information electronically, so they get really this information or this designing on tapes, not on paper, and they are introducing this in their engines, in their computer systems, are going ahead with this, and then they are really making a perfect job from the beginning.
So with the parts that you buy, is it an all German engine?
This is, let's say, a European engine, or even a metropolitan, an overworld engine. We have parts from America, we have parts from Italy, a lot of parts from Italy, from France, from England for sure, and of Germany for sure too, yes.
So what do you have to do? Once you've designed the part, do you then send them the tape and they start producing, or is it a question of waiting around and then doing more tests before you?
I didn't understand the
Oh,
question.
okay. All right, start. Okay, stop there then. Right.
Now
Sure.
we are moving around
Yeah.
some megabytes,
Yeah. Okay.
and from time to time the machine is.
Yeah. No. Okay. Well, it's, again, not a problem really.
Bevor es abstürzt, lassen Sie stehen, so wie es ist.
Yeah.
Das probieren wir mal.
Oh, that's it. Great. Absolutely brilliant. Yeah. Lovely. Yeah. And see how it's moving. All right. Okay. Right. Then. So then you've got. Oh, sorry. So what you've got here is a German engine, or is a product from around the world?
This is coming from all over the world, wherever we can get the best parts we need for our purpose. So we have parts from America, we have parts from England, we have parts from Italy, and also as well from Germany or France.
And I suppose this computer technology that you've got here now it virtually enables you to design, send the design by computer and almost have the part produced very quickly.
Yes, this helps us to produce very quickly because the informations are precisely closed, and most of our suppliers are able to continue their job with the data we are sending to them on a tape or on a disk, so we don't have to work the way about the paper where certain misunderstandings could arrive.
Okay, great.
I keep it going, Chris.
Some awesome would have fast.
Okay, just stay there.
Can you just talk?
Yeah.
Yeah.
Okay. So just again, just point out different things on the engine. Use your hands as he works
Yep.
away, and just literally point to various things like that, and the camshaft. Right. And where's the oil pump on this then?
The oil pump is on the other side.
Right.
So it's,
Yeah.
should you go there?
Yeah. Just move around.
Here, oil.
Yeah.
Okay. Brilliant. This bleeding line.
Yeah.
And this is the filter.
Yeah.
Yeah, the life for the roller.
Yeah.
Cooling system. Can also come to the front zero and press it. Here in the stage. All the wheels. Here is this remark. This is the drive. This is the tension. Belt tensioner. Which is the practice. He never had this school like this. Only the first day. First day I see what then it is. Because the glow is so far up, the edges are some far in the ear bit. No. Is it real? Fish, wait, it's all kind of I didn't know much. It's just was good. Wenn es Gesicht ist, Sport, wie gut war, da war es dick wieder. Wait, all I know, wir will the till the next week, because this engine that should really is the me. It was the eagle and shit. Holy. Because of hard to see. Bubble back. Jews that are dead. She's did you share? Spustie, what it by bar. But oh, we know, probably we don't have several. The power is so bad. We should you. So the would we? There's we and to responsive bang the Asia. And we already had no paper this station open, they can look at screen, but and that we don't discuss about money. That's just out the door. This asked this, it's say, oh, here a little bit there later. They got an influence of the environment of the me so much dead and after builder is so sad. They like me the eat off and then yeah, sorry God, this is but what is the edition that was this it there come look really dingy. The pop is bizarre. What? You in this should it be a bit chat? Did you find it? My watching the prime editor. Considering this passage, there are also part of the skill. Yeah, that up. But people actually like here's the A6 is pretty. Only the A8, educate sometimes the opportunity to go there to do this to do it there. There you see cemented words. Stuff. Really working. Well, they yes, but also there are a lot of robots, but they are more into this. Like some of the